for a little bit, okay? But I kind of told you that these were some things that we're going to continue to use as we go throughout the rest of the year. And so we're going to kind of bring in some previous knowledge on some of these things to kind of help us out. So as I look at these two problems up here, kind of a warm-up type problem. The diameter is 12. The diameter of circle C is 12 on both of these problems. Now, both of these problems, they look a little bit different. So in this case, the diameter is the line that goes from one side of the circle to the other, but it has to go through the center, okay? So we know that this entire thing here is my diameter. If the diameter is 12, then what would my radius be? 6, okay? It would be half of that. So what I could then do is I could label all of my radii as 6. We got 4 of them, okay? And maybe we don't need all 4, but I'm going to go ahead and label all 4. Okay? Secondly, what we're trying to find here is we're trying to find x. Now what I'm going to do here is I'm going to redraw this triangle. And I'm going to label the parts that we know. We know that we have a 90-degree angle, pretty important piece of information. We know that we have a right triangle with 2 sides. These 2 sides are what we call the legs. What do we call the third side? The hypotenuse, okay? Now, there's a couple of different things that we could do here, okay? There's, I think, what we call an easy way, and maybe one's a little bit harder, okay? We could do the Pythagorean theorem here, okay? And I don't think that's necessarily a hard way, but I think there's an even easier way than doing the Pythagorean theorem on this one. Not only is this a right triangle, but what else can we determine about that right triangle? What do we know about the angles? What do you think? They're congruent, okay? Because these 2 sides are congruent, then these 2 angles would be congruent. And not only are they congruent, but what would the measure of those 2 angles have to be? 45, 45. Okay, so we haven't seen it for a while, but there we go. We have a good old 45, 45, 90 triangle. If we can remember those relationships, and remember you have those little triangles that we made. If you need to pull those out, hopefully you didn't toss them. The 45, 45, 90 is A, and A radical 2. So the hypotenuse then simply would be 6 radical 2. And that would be our answer. Okay. Now, could I get the same thing doing the Pythagorean theorem? You would. You would just have to simplify the radical, but we should end up with the same answer. Okay. So that's one thing we haven't seen for a little while. On the one on the right, we don't have any of the diameters given to me. We don't have a line that goes all the way across, but by knowing that the diameter is 12, the radius is 6. So any segment that goes from the center to the edge of the circle is going to be 6. Okay? I could even do the same thing here, but I'm going to wait on this one because what we're seeing here is that these 2 pieces are the same. So if this whole thing here is 6, then how much do each of these pieces here have to be? We're just going to split it, right? This splits right down the middle. So each of these would have to be 3. Okay, now I'm going to draw the triangle. I think it's helpful to draw the right triangle. We know this is 6. We know this is 3. And we're trying to find this piece right here. Okay. Now, we don't really know the angles here, okay? And I will talk about the angles here in just a second. But we don't know that right from the start. So probably the best thing to do here, if I know 2 out of the 3 sides of my triangle, then here's where I can use the good old Pythagorean theorem. Okay? And that's a squared plus b squared equals c squared. So we're going to go x squared plus 3 squared equals 6 squared. Okay? So these are just some things that we've used and fairly recently. I mean, it wasn't like all the way back in September. It was maybe about a month ago. But these are some things that we're going to have to pull out and be able to use today. We would subtract 9. Okay, and now here's the issue is that 27 is not a perfect square. Okay, and so when we write our answer here, it kind of depends on how they ask us to leave it, and a lot of times they're going to ask us to leave our answer as an exact answer, which means we're going to leave it in simplest radical form. So when I take the square root of 27 here, this is where we could do the tree, right? We break it down. So what is something that would go into 27? Okay, 3 times 9. 3 is prime, so we're done with it. 9 breaks into 3 and 3. Okay, so if I were to rewrite this, 27 is really 3 times 3 times 3. And what we look for is we look for pairs. We look for groups of 2. We have one group of 2, and then we got an extra 3. That's not paired up. So we're going to bring the 1 pair out, and we're going to leave 1 on the inside. So that would become 3 radical 3. Okay, that would be our exact form. Getting the decimal form, not a big deal. You could put that into your calculator and you could get the decimal for radical 27 if they ask for a decimal. So I'm not worried about the decimal part. That would be a calculator piece. Putting it in simplest radical form is something we haven't really done for a while. Now, I told you that we would do or talk about the angles here. We don't really know this, but this one does end up being a 30, 60, 90. The only way I would have been able to determine that based off the original information is that the hypotenuse is 2 times longer than this. So once I recognize that, then I could say that this side here is whatever k is times radical 3. So that might have been a little bit simpler if I would have been able to determine the angles, but most of us probably would just go to the Pythagorean theorem on something like that. But either one would work there. But don't always assume that it's a 30, 60, 90 right from the start, okay? Unless we have some more information given to us. Okay, yesterday we had some theorems. Today we got a few more theorems. All of these theorems deal with circles in some way or shape or form. We're just doing different things with circles each day, okay? So this first one, congruent corresponding chords, congruence theorem, okay? If arc AB and arc CD are congruent, then AB and CD are congruent. And it can work either way. If I know those two segments are congruent, therefore the chord or the arcs could be congruent. Okay? So we got to know one or the other. If I know the chords are congruent, I can prove the arcs. If I know the arcs are congruent, I can prove the chords. We don't necessarily know the length of them. We just know they're congruent. Okay, this one here, perpendicular, we've seen that a lot. Probably one of the most common words that we've seen throughout this whole year, right? Perpendicular means two pieces that are making a 90-degree angle. And we see that right here. We see the 90-degree angle. So we see that EG and FD are perpendicular. We see that they're forming a 90-degree angle, right? And it tells us that here as well. If the 90 wasn't here, the information here would be provided. If that's the case, then what's happening is HD and DF are congruent. So what I can do here is I can say these two pieces are congruent. So that means that it's bisecting that chord. The difference here is this one goes through the diameter, this one goes through the center, this one does not. So if the diameter splits another chord, it's going to split it in half. Okay, and that's basically what we're talking about here. The other thing that would be true is that arc GD would be then congruent to arc GF. So not only is the chord split in half, but that arc is split in half as well. So there's two pieces there that we can determine. Okay, and then I can do the converse of that. If I tell you that these two pieces here are congruent, then that tells me that SQ is the diameter. And I can either call it SQ or QS. No center is given to us here. So we don't see the center on this circle, but because these two pieces are congruent, then I know that SQ is going through the center, okay? Even if there's no center given to us, I can conclude that. So same thing we just talked about on the previous one, but different information is going to be provided, okay? So just a little bit different topic on that one. Okay, some of these problems are going to be easier than others today. Some of them, it's just a matter of looking at it and being able to identify what's going on. It may not be a whole lot of work. Others, there's going to be a little bit of work involved to get where we need to be. Okay, on this one here, it says that, or it has it marked, that GF and JK are congruent. Okay, so we know segment GF is congruent to segment JK. If that's the case, then we know that arc GF is congruent to arc JK. So if the segments are congruent, the arcs are congruent. And when I talk about the arc, remember I'm talking about the piece that's on the outside of the circle, outside of that segment, okay? G to F and J to K. It's the minor arc that we talked about yesterday. And it tells me in the picture here that JK is 80. So what we can simply do is we can say the measure of arc GF is 80 degrees. Okay? We've seen this little m throughout the entire year, right? Little m, we see that a lot, like when we talk about angles. And here we're talking about degrees again, so we're going to see that symbol again. So just know when you see that little m, it means measure of the arc, okay? And you might see that with angles too, measure of the angles. Okay, same thing here. BD and AC are both 9. So we know that BD is congruent to AC. So if those two are congruent, that means the two arcs are also congruent. So that means that AC, the measure of arc AC, has to be, BC, not AC. Should have put BC here too. Measure of arc BC is also 110. It would be the same as this arc here. Now, I know you can't see it on your guys' book, but we have it highlighted in red here to show which one we're talking about. That's that piece of the circle that we're looking at. So those are pretty easy. Just a matter of looking at it. Okay, these are the two pieces that are the same. So what is the measure of it? Okay, no, not really any work involved. Now, when we get down here, using the diameter, hey, which one of these segments is the diameter of the circle?
JL.
Okay, how come, Hannah?
Because it's passing through the center and it's perpendicular to HK.
There you go. Okay, right here. Okay, it has to go through the center. HK is not a diameter. Okay, that is just what we call a chord. That's really, really important. Sometimes maybe they're both diameters, but in this case, the only diameter is JL. So I'm going to identify that JL is the diameter, just so we know which segment is the diameter. Okay, using what we talked about on the previous page, we said that if JL is the diameter, then it's going to split HN and KN. to be equal to one another. Oh. Okay, and it's kind of hard to tell this. M is the center. N is this little point right here. So if NK or KN is 7, then what does HN have to be? 7, okay? And so HN is 7. Okay, what we're trying to find is HK. We're looking, really pay attention to what's being asked, okay? HK is the length of this whole thing. So if this is 7 and this is 7, then that means that HK is 14. It's the length of the whole thing. Okay, what would be true about these two arcs? What do you guys think? What could we say about those two arcs? They're congruent, okay? This arc and this arc are congruent because those two segments are congruent, okay? And it's the diameter is splitting those two. So I know that HJ is congruent to JK. I know those two are congruent. And we know the expression for HJ is 11x. So we're going to take 11x and we're going to plug it in for HJ. And we also know that JK is 70 plus x. So we have an equation that we got to solve. And if we want to solve this, we got to get our x's together. So we're going to subtract x from both sides. So we get 10x equals 70. And we would get x equals 7. Okay. Here's the part that I think probably will get missed the most, either today on Big Ideas or tomorrow on the quiz. We don't do a good enough job sometimes of reading the instructions, okay? Some people will just stop right here and will say, okay, x is 7. But the question's not asking us what x is. It's asking us to find the measure of arc HK. So h all the way over to k, kind of like we did yesterday. So I got to take 7. I got to plug it in here. 7 times 11, 77. Okay. On the other side, 70 plus 7. Those two better be equal, right? And that's kind of a good way to double check to make sure I'm doing things correctly. And they are equal. So to find out what the measure of arc HK is going to be, is I would take 77 times 2. And that would be 154 degrees. Okay. There's probably 4 different questions that they could ask me there. They could say find x, and we'd be done. They could say what is the measure of HJ, what is the measure of KJ, or like we did here, what is the measure of HK. I probably could even say what is the measure of this guy right here, even though I don't have anything down here. What would I do to find HL? If I had to find HL. What does JL do to that circle? What did we say yesterday? What do we call JL in this case right here? What's the word for JL? It's the diameter, okay? And the diameter splits a circle in half. So how many degrees is a half circle? 180, right? So if I know this piece here is 77, then the rest of this would be 180 minus 77. Okay? We're not asking that in this question, but those are questions that could be asked, right? So I'm just kind of trying to bring in some of the things that we did yesterday and where we could use them again today. Okay, on this next one, find the measure of FB. Okay, FB and BD. Once again, A is the center of the circle. So it's the diameter. It's going through the center, and it's 90 degrees. So I could simply here just say x plus 5 equals 2x plus 6. because I know that these two pieces would be congruent to one another. It's bisecting it, right? That's one of the things that we talked about. It's one of the theorems that we're doing today. Now, when we do this, here's where it gets a little bit weird. If I solve for x here, I get x equals -1. And some people freak out here because we get a negative, okay? We can have x be a negative value, but we can't have a length. If I'm saying the length of something is a negative number, something's wrong. We can't have a negative length when we're talking about the length of a segment. But x can be negative. So when I plug negative in here, I better not get a negative answer. Okay, so here's how I would check it. -1 plus 5 is 4. And we're trying to find FB, so I could also go 2 times -1, which is -2, and -2 plus 6 would also be 4. So FB is 4. Okay, this one over here, same thing. Only difference is we're talking about arcs rather than segments. So what you got to really be careful of is, are we talking about a length or are we talking about degrees? Okay, in this case here, the one thing that you'll see over and over again today a lot is that pieces are going to be congruent as long as we can prove they're congruent. BD is the diameter, so it is splitting this arc in half. So I know these two pieces are congruent. Once again, I could add x to both sides. I get 10x equals 80, and then I get x equals 8. I got to plug it back in. I want to find the measure of arc CE. So really pay attention to what arc. We want this whole thing right here. So I got to take 8 and plug it back in. 9 times 8 is 72 degrees. 80 minus 8 is also 72 degrees. So the measure of arc CE is 144 degrees. We got to add those two together. Okay. Once again, there's a lot of questions that could be asked there. I could ask you for this or this, and this time we're asking for the whole thing. Okay, this is the way I probably would write it out. They wrote it out in words, measure of arc, CE. I would just use the symbols. Little m means measure, and then the symbol for arc, CE. Okay, I will tell you this for tomorrow, since we got a quiz. There's a lot of theorems here. These theorems, I don't think any of these theorems are like overly difficult. We just got to kind of remember the difference between them. So I would recommend going back and looking at some of this tonight or tomorrow before the quiz to kind of remember some of the things. Section 1, we haven't done Section 1 since last Thursday. So it's been almost a week since we talked about all the different vocab at the beginning of the chapter. Chords, diameters, radius, those things are things that you might want to go back over as well. All right, here's another theorem for today. Equidistant chords theorem. So first of all, a chord is a segment that connects 2 points that are on the circle. So here, AB and CD are both chords. In this case, if I have one circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Okay, so if I know that if FE is equal to GE, and that's why both of these are forming a 90-degree angle with those chords, is I know that they're going to be the same distance away. So we do need a 90-degree angle there. If FE and GE are equal, then I know that CD is equal to AB. Those two would be equal to each other. Those two segments would have the same length. But they have to be the same distance away from the center. I think the hardest part to these problems today is we got a lot of stuff going on in this circle, right? And trying to take the information that we have and use the information that we need. So in this case here, Sometimes they give you information like at the top of the problem, like in the instructions. Sometimes it's labeled on the circle. We got to put all that together to what we need. Okay, so in this case, QR and ST are both 16. Okay, one of the things that helps me here is QR is a chord. WX, not only is it a chord, but it's actually diameter, right? WX goes through the center. So what is WX doing to QR? It's bisecting it, you bet. Okay, so that means these are both 8. QR was 16. We know it's bisected because this goes through the center. Okay, this one down here is not bisected because this segment here, it's going through it. Okay, but it's not the same length. Okay, and so that one's a little bit different. Mainly because what we notice here is this one had a 90, this one does not. Okay, that's the biggest difference here. We see a 90-degree angle versus this one does not have a 90-degree angle. Okay, what we want to do here is we want to find the radius of circle C. In order to do this, we have to draw in a segment that we don't have right now. We have to draw in using information that we already know. And so what I'm going to draw in right here is I'm going to draw in QC. The reason I'm drawing in QC, first of all, QC is a radius, right? It connects the center to the edge of the circle. The reason I'm drawing that radius in is because we have a right triangle. I know that this piece is 8, and I know this piece is 2x. And we're trying to find the radius. So I'm just going to call it r, because we don't know what the radius is. And you might say, oh my gosh, we got 2 different variables here. And that would be true, okay? QR and ST are both 16. We're going to use, and this is one thing we have not used yet. Notice that this down here is 5x minus 9, and this is 2x. Okay, because these are both perpendicular to 2 chords, then we know that UC is equal to CV. UC is this little piece here. CV is this little piece here. Okay, we know those 2 pieces are congruent. Okay, UC is 2x. CV is 5x minus 9. Because those 2 pieces are equal, I can set them equal to each other, and now I can solve for x. So now it's just a 2-step equation. I'm going to subtract 5x, and I'm going to divide by -3. And I get x equals 3. Okay, the reason that's helpful is because now that I know what x is, I can take 3 and I can plug it in for x right here. So now 2 times 3 becomes 6. And so now we have the Pythagorean theorem. 8 squared plus 6 squared equals r squared. So there's where the Pythagorean theorem comes into play. That's not something new today. That's something we're going to have to pull in to be able to use. That's why we talked about it at the beginning of the lesson today. 64 plus 36 makes what? 100. Okay, and the square root of 100 is 10. So my radius is 10. And that's what it was asking us to find. That's why I like to label it as R, just because then when I know when I'm done, I've got the radius that I'm looking for. I'm probably not going to do both of these last two because they're both essentially the same thing. JK and LM both equal 24. So right away, pay attention to, okay, here's my diameter, right? The diameter is perpendicular, and so it's going to bisect JK. So right away, I can say that JP and KP are congruent. I know that the entire length is 24, so I could say that this is 12, and I could say that this is 12. 24 divided by 2, okay? Now, here's a couple of things, and here's where some people get confused. They give us some different lengths here. NP is 3x, my fault. This is 3x, NQ is 7x minus 12. I'm going to label those with different markings, okay? We know these two pieces are the same. Don't mark it with the same markings, because if you mark it the same as these two, then you're going to automatically think these are both 12. They are not 12, okay? These two are congruent and these two are congruent, but they're not the same length. So you got to really be careful there, okay? You got two different pieces that are congruent to one another. So what I'm going to say here is that NP is equal to NQ. We know the length of NP. Is 3x. We know the length of NQ is 7x minus 12. So now we can solve it. Subtract 7x. Really watch your signs. We get x equals 3. What I'm going to do here is I'm going to draw in this triangle. This is the triangle that I'm going to use right here. I like to redraw that triangle. If you want to label it with the letters J, P, and N, just so you know what triangle you're talking about, that probably wouldn't be a bad idea. We also know that it's a right angle right here. We know that JP is 12. Just a second ago, we said that x is 3, and we know that NP is really 3x, so 3 times 3 would be 9. And once again, we're looking for the radius. This segment is not drawn in, so we have to kind of draw it in on our own. We're going to draw in segment JN. And then what are we going to do to find R? Pythagorean theorem again, okay? Okay, so what we're going to do then is we'll go 12 squared plus 9 squared equals R squared. Add those together, we get 225, and then take the square root. And we get a radius of 15. Okay, I will tell you on this last one here, it's same idea, a little bit different information is given to us. We know these two pieces are congruent, and they tell me that they're both 5. Okay, I'm not going to go through the whole thing and solve it for you here. JK is 5x minus 1. LM is 7x minus 11. Okay, what would we know about these two segments right here? What would be true about those two segments? JK and LM. They're equal to each other, okay? So I'm going to take this expression instead of equal to this expression. We're going to plug it back in to find out what the length of JK is, and then we can split it in half, okay? So They give you a little bit different information, but it's still essentially the same idea, okay? Just provided to you a little bit differently. Okay.